Hey guys, Mrs. Young here. We are going to read this next little section in our book. Now, if you are comfortable binding this on the online book with the McGraw-Hill app, that would be pages NOS 6 and NOS 7. But I'm unable to mark all over that online book as well as I can the reading essentials. So you'll notice that this is one that I've already marked up really from last year. This is a Methods of Science reading essential. This is what is in your Notability from kickoff day, okay? All right, so we have already read these two sections in class. We are also going to fill out our outline notes. And so if we take a look at that real quick, then that's this one right here. And I have gone through and double checked that we have all of that filled in. We have already done these two sections of our outline notes. So if you do not have these A and B already filled out from last week or so, then please pause this video and split screen that with your outline notes, making sure that you indeed do have these first two sections filled out, okay? So we are just going to do the section on scientific inquiry. So follow along with me in your reading essentials, and you can mark that text, or you can read on your own with the online McGraw-Hill app that is on your iPad, okay? All right, so choose the book that you would like to use, but I am going to flip back over to our reading essential. So that's what it looks like right here, all right? So we are ready to roll. Okay. Scientific inquiry, also known as the scientific method. Now I have gone through and I have already marked this text, so I would like for you to be marking it like I have, all right? So I've highlighted the important things for you to know from this section, okay? All right, let's roll. When scientists conduct scientific investigations, they use scientific inquiry. Scientific inquiry is a process that uses a set of skills to answer the questions or to test ideas about the natural world. There are many kinds of scientific investigations and many ways to conduct them. The series of steps used in each investigation often varies. The flowchart in the figure below and on the next page shows an example of the skills used in the scientific inquiry. Alrighty. So we are going to start here, right here, guys. Start here at making an observation, whether that be a quantitative observation having to do with numbers or qualitative observations having to do with your senses. But that's where you're going to start. You're going to make an observation, and then you're going to ask a question about that observation. Why is that? What is going on? But you first have to make an observation. So you're going to observe and question. So you're going to state a problem, you're going to gather some information, then you're going to infer. So moving it to the next step, we are going to write a hypothesis. And our hypothesis is an educated guess. All right, we've talked a little teeny bit about the idea of a hypothesis. We will move forward and be writing a hypothesis very soon. So you're going to make a hypothesis. This is what I think is going to happen. Okay, so you're making a prediction. So then, after you make your hypothesis, well, then you need to test that hypothesis. So this is where you are it's going to be what you do. All right, so the biggest ones that you think of when you think of science is designing an experiment or creating a model, making a model. But it also can be collecting data, doing research, recording observations. So it's going to be what you do. First, you make an observation, then you make a hypothesis, and then you design an experiment, okay? So I'm going to skip over here. So then after you do that experiment, then you are going to look at the data. You're going to analyze your results. You might create a graph. You might classify it. You might need to do some calculations, some math. All right, so after you analyze your data, what happened? You're going to draw a conclusion. You're going to infer. You're going to summarize. So then you're going to think, when you come up like this direction, was your hypothesis supported? Was what you thought was going to happen, did that actually happen? So we are going to say yes it is supported, and that is going to send us back up to here, where we now have to repeat our experiment. We're going to repeat several times to confirm. So confirm, you're going to do the experiment, analyze data, draw a conclusion. Was my hypothesis supported? Yes, you're going to do it again. Round and round and round you go, at least 3 trials, just for reproducibility. All right. So that's what happens if your hypothesis is supported. What happens if your hypothesis is not supported? What if what I thought was going to happen didn't happen? All right, well, that's going to send me back to my flow chart here. So I'm going to have to come back. I can't go and redo like when my hypothesis was supported. I need to come back over here and perhaps I need to rethink my hypothesis. I have to look at it again. All right, and maybe make a new hypothesis. I might need to modify or revise my hypothesis. I might need to rethink it, redo it. All right, and then I'm going to continue on the same path that once I have created a new hypothesis, then I'm going to test that hypothesis. I'm going to design an experiment, maybe tweak the experiment I was doing before. And then let's come back down here. I'm going to analyze my data. I'm going to draw my conclusions. Am I still not supported? Well, I got to go back to the drawing board and I need to rethink and redo. Or was my hypothesis supported? I'm going to come back up here and now I'm going to repeat, doing it a few times to confirm my results. All right. So I've gotten to the point now where I am ready to do my last step. I am going to communicate my results. This is what you did with me when we did the gumdrop lab and you did your lab report. You're communicating your results with me, but you're going to maybe, a scientist might write a journal article or speak at a conference or exchange information on the internet. There's lots of different ways for exchanging information. You might need to share a lab report. You might need to do a presentation, share this lab report with your boss, but somehow communicate what you did, okay? That's the final step. So to rethink that or re-look at this, you're going to start here. You're going to make an observation and question. Have a question, pose a problem, state a problem, write a hypothesis, test your hypothesis. That's the doing of your experiment. You're going to come down here and analyze your results and draw a conclusion. Was your hypothesis supported? Yes. Then you're going to redo that experiment a few times just to make sure that you have reproducibility to confirm. But if your hypothesis was not supported, well, back to the drawing board you go, and you need to rethink your hypothesis and go through the process again until you are ready to communicate results. You're going to share what you did. You're going to share it with someone else, okay? All right, so let's take a little closer look at all of those, all right? So at any point, guys, if you need to stop and you need to pause, because I had a lot written in here. Remember, I had done this writing beforehand, so this would be a great place for you to pause this video and for you to make sure that you have everything written in your notes that I do, okay? All right. So, asking questions. One way to begin a scientific inquiry is to observe the natural world and ask questions. So here's a vocab word for us. Observation is the act of using one or more of your senses to gather information and taking note of what occurs. Now we know that that might be qualitative when we're looking at what that object looks like, smells like, tastes like, sounds like, feels like. Or is it quantitative? Is it something doing with numbers? There are 7 birds, or it's 6 inches, or it's 32 degrees, some type of measurement. Suppose you observe that the rivers of a bank have eroded more this year than last year. You want to know why. You note that there was an increase in rainfall this year. After these observations, you make an inference based on these observations. An inference is a logical explanation of an observation that is drawn from prior knowledge or experience. So I'm going to put a little star here, there, and there, just to remind you that those are two vocab words that you are going to come back and put in your vocab assignment. You infer that the increase in rainfall caused the increase in erosion. You decide to investigate further. You develop a hypothesis and a method to test it. So a hypothesis. A hypothesis is a possible explanation for an observation that can be tested by scientific investigation. It's got to be tested. Cannot be based on opinion, right? A hypothesis states an observation and provides an explanation. You might make the following hypothesis. More of the riverbank eroded this year because the amount, the speed, and the force of the river water increased. Because there's more rain, there's going to be more water coming through, and that water rushing through the banks of the river is eroding that, just like pouring water on a sandcastle. You're going to break down the walls of that sandcastle. That's erosion. So scientists often use a hypothesis to make predictions. A prediction is a statement of what will happen next in a sequence of events. Scientists make predictions based on what information they think they will find when testing their hypothesis. We've done some work with predictions and making observations and making inferences, as when we did that OPIC stuff. Okay, a prediction for the hypothesis might be, if the rainfall increases, then the amount, the speed, and the force of the river will increase. So a hypothesis we're going to learn is an if-then, and we're going to go on and add the because statement. They have just the if and the then. If the rainfall increases, then the amount, the speed, and the force of water will increase. So if and then we're going to go on and write because. If the amount, the speed, and the force of water increases, then there will be more erosion. All right, so we're going to come down and test that hypothesis. It's what we are going to do. When you test a hypothesis, you often test whether your predictions are true. If your prediction is confirmed, then it supports your hypothesis. If your prediction is not confirmed, you might need to modify your hypothesis and retest it. There are several ways to test a hypothesis when performing a scientific investigation. You might design an experiment, make a model, gather and evaluate evidence or research, or collect data and record your observations. For example, you might make a model of a riverbank in which you change the speed and the amount of water and record observations and results. So on your study guide, there is a section that asks for the ways to test a hypothesis. All right, so that is going to be up here. And then it's also in this section here. All right, so don't skip that. Analyze results. After testing your hypothesis, you analyze your results using different methods. Often it is hard to see trends or relationships in data while collecting it. Data should be sorted, graphed, or classified in some way. After analyzing the data, additional inferences can be made. So you take a look at all that information that you gathered. So now you're ready to draw a conclusion. Once you find the relationship among data and several inferences, you can draw conclusions. A conclusion is a summary of the information gained from testing a hypothesis. Scientists study the available information and draw conclusions based on that information. So now we are ready to share the results. An important part of the scientific inquiry process is communicating results. Ways to communicate results include writing science journals, speaking at science conferences, exchanging information on the internet. Scientists might share their information in other ways too. So for you guys, it's going to be like some type of lab report that you would turn into your science teacher. Scientists communicate results of investigations to inform other scientists about their research and the conclusions of their research. Scientists might apply each other's conclusions to their own work and help support their hypothesis. So they want other scientists to go out and take a look at their experiments. So that's why they are going to need to write very clear instructions and clear details. So if there's a scientist on another part of the country who wants to take a look at their experiment, they need to be able to one, reproduce it, set it up like that scientist did, and have it be understandable. All right, so our last little section is further scientific inquiry. Scientific inquiry is not completed once one scientific investigation is complete. If predictions are correct and the hypothesis is supported, scientists will retest the predictions several times to make sure that the conclusions are the same each time. If the hypothesis is not supported, any new information gained can help revise the hypothesis. Hypothesis can be revised and tested many times. All right, so I'm at my line there, which indicates that we are done with this section. We are now ready to go to our outline notes. So this is for the first two little sections that we read together in class last week or so. If you did not read these two sections, it would be on the reading essentials, just the little section prior to the one we just read, okay? All right, so let's take a look at our outline notes. Scientists use scientific inquiry, which involves a varied series of skills when they conduct scientific investigations. Scientists often begin scientific inquiry with observations, the act of using one or more of your senses to gather information and take note of what occurs. After an observation, scientists might make an inference, which is a logical explanation of an observation drawn from prior knowledge or experience. Okay, so if you are not caught up with these words, pause this video. All right, so I have already typed these in, so you guys can't type as quickly as I can talk. So make sure you pause, guys, as often as you need to make sure you have everything. All right. So a hypothesis is a possible explanation for an observation that can be tested by scientific investigations. Scientists often use a hypothesis to make predictions, which are statements of what might occur next in a sequence of events. All right. So scientists test a hypothesis by doing one or more of these steps. They're going to design an experiment, make a model, gather and evaluating evidence, record data, and record observations. After scientists have tested a hypothesis, they analyze the results. So that's where they're going to stop and take a look at what data that they have collected. Scientists draw conclusions based on relationships among their data. They're going to take a look at it. Do I have any trends? What am I noticing? A conclusion is a summary of the information gained from testing a hypothesis. Scientists communicate their results to inform other scientists about their research. Scientists retest predictions many times to make sure that the conclusions are the same. It's not just one and done. They have to do it again and again just to confirm that, yes, indeed, this is the outcome. All right. Okay. So this is as far as we are going today. Results of Science is going to be on another day. So make sure that you have all of your outline notes for this section complete and that you have marked the text and the reading essentials. So what I'm going to ask you to do now is to go into your vocab assignment, and I want you to add the words that I have on today's page. Look at the in-class assignment, and then also there are sections in your study guide that you are now able to do. You can do the entire first page on your study guide. The study guide is linked on today's page. I'll link it again, as well as under your student resources on the homepage. All right, reach out if you need anything. Nothing to turn in today. All right, the vocab assignment, not turned in. The outline notes, not turned in. Study guide, not turned in. Okay, we're just starting that. So nothing to turn in today unless it is missing work. Okay, all right, guys, you have a really good day and hope